Happy New Year, everyone, and welcome to the January General Meeting of the Kalamazoo Astronomical Society. Of course, this isn't exactly what we've had planned. We were really hoping to have a hybrid meeting. We were hoping to have a big crowd at the Kalamazoo Area Math and Science Center. We were going to show Jay Anderson a great time, take him to lunch, take him to dinner and all that stuff, show him around town. Over a year of planning, then, oh, the weather's bad. Have to cancel plans, have to cancel all the preparation we made and go to Zoom only. So thank you all for joining us on this winter evening. I mean, especially if you live maybe in the Northeast or, of course, right here in Michigan. Hey, there's nothing better to do, right? Right? What are you going to do? Watch some boring thing on Netflix or Disney Plus or pop in some movie you've seen 1,000 times? No, you want to join us for the general meeting of the Kalamazoo Astronomical Society, and I forgot to mention the fourth installment of the Eclipse series. So let's jump right into it. Let's not wait anymore. Let me introduce our special guest speaker immediately. So tonight's guest speaker first joined us in 2017 for Astronomy Day. He is a Canadian meteorologist and an avid eclipse chaser who, for over 40 years, has published studies of the climate along eclipse tracks to help those who want to place themselves in the most favorable place under the lunar shadow. And these studies were originally incorporated into the circulars of the U.S. Naval Observatory, and then with co-author Fred Espenak by NASA. He has a Bachelor's of Science degree in Physics and Astronomy from the University of British Columbia and a Master's degree from the University of Manitoba. With Fred Espenak, you'll see him in March. He is co-author of Eclipse Bulletin, Total Solar Eclipse of 2024. He also created Eclipsophile, a website that provides climatology and weather information for celestial events. Since his first eclipse in 1979, he has traveled the world with his wife Judy to stand under the shadow of the moon. And the eclipse on April 8th will be his 34th total solar eclipse. So without further ado, please welcome Jay Anderson.
Thank you all. Thank you all very much. Because after 34 eclipses, you can probably guess I'm not a spring chicken anymore. So I'm going to share my screen here and we'll get started on this. And there we go. Moonshadow Madness and Eclipse Journey. Well, what am I talking about here? Well, I'm going to talk about eclipses, but I want to focus a little bit on something that really appeals to most people who go to eclipses, and that's where they go to see it. And here we have two pictures of the eclipse shadow on the Earth. One in 2017 went across the United States, and I know many of you probably went and saw that and certainly watched partials at home if you didn't. And then one in 2021 where the eclipse was down in the south, in fact in Antarctica at that time. Before you can go to an eclipse, you have to know where it is. And up until the 1600s, they could predict that an eclipse was likely to happen or was going to happen, but telling where it is became quite a bit more of a challenge. Even as early as 700 BCE, the Babylonians were able to say, well, it looks like this month could be an eclipse month. We're going to go out and watch for it. And they would do that at 5 and 6 month intervals because that's when eclipses typically occur, or at least the deeper eclipses. And if they didn't see it on the 5th month, they'd go to the 6th month. And sure enough, they would be able to see it if it was visible there. And if it wasn't, they would speculate that it was seen somewhere else, but not over Babylon and those environments. You get up to 1605, Johannes Kepler wrote this paper, which you can see here on the left, and the translation of the title is there on the right-hand side under the arrow. But it's pointing out that it's directed to the people in Spain, further Gaul, that means in the southwest corner of France, island of Corsica and Sicily, about the eclipse of the sun. And you take a look at the eclipse track there. He got most of it right. It didn't actually go over Corsica, but instead over a little bit farther south in Sardinia. So at this point, he proved that he could predict the eclipse track well enough, but the thing is he made this prediction after the eclipse, and what he was wanting to do with this letter that he's sending out is ask his friends around Europe what they saw so that he could check to see how accurate his prediction was. We have to jump ahead for over a century when we get into England and Edmund Halley, who's probably best known for Halley's Comet. But Edmund Halley realized that using Newton's theories and the increase in knowledge over the century since Kepler, that he could actually predict the path. And so he had this map drawn up, which shows the eclipse shadow actually going almost centrally over London. And after it was over, he went and surveyed people out on the edges to find out how accurate he'd been, and found out that he was about 20 miles off in the position. Well, because he published this ahead of the eclipse, it was possible for people to come. And one person did, one I know of, traveled from Paris, and that was the Chevalier de Louville, who, and his full name's there in the brackets, who came from Paris to London. And he was there with Isaac Newton and Halley and the other leading lights in England at the time. So we've sort of identified de Louville as probably the first person that traveled to an eclipse. It wasn't an easy trip for him. Road travel in England and France, roads were hardly worth traveling on. You had to use a carriage like the one that I've shown on the left-hand side here. And you also had to take a boat across the English Channel, and either a small one or a medium-sized one. You can see here that 5 miles per hour, 8 miles per hour was about the best you could do on a trip like this. You didn't travel at night because there were a possibility of being robbed. And so you had to put a considerable effort into it to go and see an eclipse. And there is a bit of a rumor that he may have been a spy for the French military, because he was also a military officer. But if he was, he had more to say about the eclipse than anything else. If you're lucky and you were in London in 1750, you didn't have to go anywhere. And that's what happened to me in Winnipeg in 1979, when the first eclipse I saw went right over top of me. And so here I am with my trusty Celestron 8 and my brother-in-law trying to observe this thing. It looks kind of milky on the sky, but we actually had a pretty clear day. So it was eclipses were a luxury item, given the problems with traveling in Europe. And as we came up into the latter half of the 1800s, the roads got a lot better. But even so, it wasn't expensive. It was time that took a lot of time. And so people were mostly well off and traveled as private citizens, and not very many of them did that. But after a while, scientists became more and more interested in eclipses as a method of studying the sun, and actually at first time beginning to realize that there were things like coronas and chromospheres and prominences and other things which we'll talk about. And they started to go to these eclipses initially, as in the lower left here. In Spain in 1860, they brought along their wives, their children, they brought along friends and their wives to go along with them. Kind of a, hey, I'm going off to Spain to watch a solar eclipse. We're going with a bunch of guys in telescopes. You want to come along? And they did. But when you get up to 1871, that's on the right here, you see a lot more equipment that's coming in and a lot less room for amateurs. In fact, they stopped taking amateurs for the most part, so the BAA, the British Astronomical Association, started to organize their own trips, and that was for the amateur members of the association. So you end up with, especially the eclipse in Spain in 1870, which was easy to reach by ship from England, a lot better than going over land. And so we have pictures here of scientists and just casual observers watching this eclipse at that time. when even the amateurs actually did some serious scientific work there at the time, particularly in drawing pictures of and showing the images of the eclipse, because photography was only just in its early stages toward the late 1800s. We get up to 1878, we had a big eclipse over the United States, and this one was essentially the eclipse that introduced the whole idea of traveling and seeing them to the American public. You could only travel by train in those days, but you can see it made enough of an impact. There's actually a couple of books that have been written recently about how important that eclipse was. And because this eclipse had a lot of publicity, it got a lot of people who are close by. Here's a picture of a group that's in Wyoming, and above the arrow is actually one of the more famous people to come and see it. That's Thomas Edison, who made a point of traveling with a bunch of his pals to go see this. The news media played it up, Harper's Weekly, after the fact. You can see the track of this going through the western United States over top of Pikes Peak. You can see that there were a lot of astronomical observations that took place on this. And the one in the center top is one that came in from the eastern United States, and it's a collection of ladies that under the tutelage of Maria Mitchell, who was a professor of astronomy in the East. I'll talk about her in a minute. She brought a group. It was well advertised. You had to go by train because nobody crossed the U.S. until about, until 1903. It resulted in some beautiful work here. But the main thing that it did is it introduced American scientists to the Europeans. Up to that point, American science, and astronomical science in particular, was kind of a poor cousin of what the rest of the world was doing. They hadn't really published extensively in it. They hadn't made many presentations and articles over in the journals that mattered, which were all in Europe. And it was after this eclipse, with the type of equipment that Maria Mitchell brought from Vassar with the other ladies in her classes, and plus all of the other astronomers, anybody who was a solar astronomer of any ilk in the States went to this eclipse. The publications that they made of it, and all of a sudden the Europeans realized that there was a lot of ability in the United States. It put them on the map as far as science was concerned. But the real person who made eclipses popular was this lady, Mabel Loomis Todd. And she happened to be married to a solar astronomer named David Todd. And he took her, or she insisted on going, to a total of 4 eclipses. And one of them that was interrupted because of the Russian Revolution and First World War. But she, after the one in Japan in 1896, she started to write a book about it. And then in Libya, she watched 2 eclipses there over a period of 5 years. And in the Dutch East Indies, another one. These books were very popular, but in fact, Mabel Loomis Todd is best known for collecting and editing the works of her next door neighbor, which was Emily Dickinson. And she also had a rather long-lasting affair with Emily's brother. So she was a woman with a bit of a reputation. And her father had actually been an assistant at the USNO, and he wrote his own eclipse book. So if you go looking, you'll find Loomis and Loomis Todd as responsible for about 4 different books. Here's Mabel's 3 books. You can see one is called Corona and Coronet. The Coronet was the name of a yacht that she traveled on from the West Coast to Hawaii and then to Japan. And the book, it deals far more with the culture of Hawaiians and Japanese than it does with the eclipse itself. You have sort of a 350-page book here, of which 20 pages cover the eclipse and the rest is about those cultures. And she was actually more of an anthropologist than she was a an eclipse reporter or scientist in this. In Tripoli, the mysterious, 2 eclipses there, and again, an account of the community, but in this case, mostly the higher social stratum of Tripoli, particularly the European part of it, which had a big European community. And the first book actually was this one called Total Eclipses of the Sun, which she did after the 1894 eclipse. So because of the popularity of these books, a lot of people get turned on to wanting to go to see eclipses. Unfortunately, after she wrote them, from the period 1901 to 1920, the number of eclipses visible in the United States was pretty limited. And in fact, only one there showing up in 1918. A couple of annular eclipses shown in red there, but the blue ones are the important ones. So you had to start looking to other places if you were a scientist and wanted to make your mark on it. And so they started sending out expeditions, and the US and Great Britain were the 2 most important countries that were sending out expeditions, and they got to be a little bit competitive, actually. The American groups developed a number of these caches, so you can actually go online and find them for sale occasionally. These caches are illustrated envelopes that are sent, in this case, from an eclipse expedition in 1930 and in 1937. Both of these expeditions took place on Pacific Islands, and they were supported by the US Navy. And the French and the British were also being supported by their own, whereas here on the left, we had an Australian team that went to Tasmania. Today, Tasmania is pretty easy to reach from the Australian mainland, but in 1910, Tasmania was a wild and remote place without a large population. So an eclipse expedition there was probably almost as difficult as an eclipse expedition that went off into these 2 islands in the Pacific. After the 1920, we started to get a few eclipses in the United States again, and this one in 1923, we have pictures of folks in California. But more to the point here, the newspapers started to talk about what people could see and started to promote that. And you're going to see a lot of that in the week to 2 weeks before the eclipse in April. People tell you they're not going to pay any attention to the eclipse. They're going to have no choice to be paying any attention to it. We had roads and automobiles then, so people could travel a little more easily to get to these things. Modern eclipse chasing, though, began with this expedition in 1972. It was organized by a few fellows over in the eastern United States. Carly Simon sang about it and complaining about one of her boyfriends. But the TSS Olympia sailed quite a long distance offshore with 800 passengers. They sold that ship out extremely quickly when it was advertised that they'd be sailing off coast to see the 1972 eclipse. And it was a good thing because the eclipse track came down over from Quebec, New Brunswick, Prince Edward Island, Nova Scotia, and most of that area was cloudy. But the Olympia, standing well out into the Atlantic, actually had clear skies and saw quite a spectacular eclipse. And you could say it's grown like Topsy ever since then. So why? Well, here's a quotation from Mabel Loomis Todd. And the word gruesome looks a little odd, but that's the way they spelled it in the early 1900s. It's a type of writing that was common in the Victorian era, a little more flowery. People used words a little more extensively, and Mabel was certainly a very good writer, to the extent that a lot of Emily Dickinson's works were modified and edited by her. But it's the corona that's the soul of the eclipse. That's why people come to see the eclipse. And even though I'm going to show you many more parts of an eclipse, that's the real appeal. You're seeing something that's only visible at a solar eclipse, and it has to be a total solar eclipse. And this is what a total solar eclipse looks like. This is my wife's photograph, and this comes from Svalbard in 2015. I have to apologize to Bob here on the right. I never did get that eclipse picture in focus, but I thought the mood that he's showing there, this sort of almost religious approach to his impression on the eclipse in Indonesia in 1983. Bob's gone on to be a very, very determined eclipse chaser. He's probably seen close to as many as I have. But so, right away, we're in two strange places in the world. A lot of people go to Indonesia, but they probably don't go into the backcountry of Indonesia, in among the volcanoes. That one behind Bob is one that's been erupting recently. And how goes to Svalbard? It's, you know, you're halfway to the North Pole in Svalbard. And yet, if you're going to see eclipses, you have to go to these places. In Svalbard, for instance, it's here you can see there's two little arrows in my map here. Svalbard is where the top arrow is, halfway between Norway and the North Pole. And the eclipse was also visible in that southern location on the Faroe Islands. So to see this eclipse, those were the only two places you could be to see it on land. And a picture on the top shows one of the eclipse groups, the one that I was with, although this is made up of many different eclipse groups, a lot from Japan, from Germany, from Norway itself, from the United States and Canada. In fact, there was quite an international gathering. A little bit off to the left out of the picture was a warming tent, because most of these folks had never encountered -20 temperatures before. That would be Celsius temperatures. But the view was spectacular. The sky was pristine clear, and you can see what it looked like just at the moment of total eclipse from that location. This is a picture of the corona that is produced by a fellow named Miloslav Druckmüller. Miloslav developed a technique to combine images from many sources and produce these extensive panoramas of the corona of eclipse. And when you see this, you begin to think to yourself, well, this is what eclipses are all about. It's about the view of that corona. Now, this is a better view than you will see by eye, unless you take some extra precautions. But if you looked at this eclipse through binoculars or even a telescope and looked at the part that's in close to the moon, beside the surface of the moon here, you would see some incredible detail in here that's only just beginning to be hinted by the pictures that Miloslav has produced here. And his website has many pictures like this from many different eclipses, and he's certainly happy to share them around with people. You'll notice there's a number of names on the bottom of this, not just himself, but 3 other people. But he actually solicits picture from anybody who wants to send them and merges them in with this technique he's developed to bring out the best of the solar eclipse. And you can see there off there to the far left in this picture, there's a planet showing up. And if you were to look at this thing closely, you'd see a lot of little stars in around it. A lot of detail. There are other people who are beginning to be able to approach his level of detail, but it requires quite a bit of hand manipulation to come up with a picture like this. So what is he seeing? So the corona, it's actually a tenuous layer. It says, I say ionized gas here, but we'll see in a minute that the corona isn't all ionized gas. It is close in. We have different names for things. We have the polar plumes, which come out from the north and south poles, or close to the north and south poles. And they're like the lines that might be radiating outward from a magnet if you were to scatter iron filings around it, tracing out the magnetic field pattern. You get the helmet streamers, which look like, well, They're supposedly named after helmets that were worn by German military in around that time, but I've also heard them described as representing the horns on a Viking helmet. Though subsequent to that, I found out that Vikings didn't actually wear helmets with horns on them. The chromosphere is that little red arc that you see up against the moon's limb on the bottom. We'll be talking more about that. In fact, we'll talk more about almost all of these things. And the prominences, which are like flames, red flames on the edge of the sun, or in this case, on the edge of the moon as well. Now, many of these things, the chromosphere, prominences, coronal loops, in fact, largely all of it, even though people in from 700 BCE onward to the 1700s saw eclipses, they never seemed to, they were so overwhelmed that they never really saw these structures and described them. You can find very, very few accounts in history where somebody mentioned red flames on the edge of the moon or something like that. It's not until you get up into the 1700s that these things really start to be described. So in a way, by learning about these things ahead of time, we're spoiling the amazement. But on the other hand, you might see a few more things instead of being so overwhelmed by the spectacle. After it's gone, you're saying to yourself, what the heck was that? You're going to say that anyway, but now we'll give you at least some idea what to look at along the way. Of course, not all eclipses show a corona, like this one that I saw in 2021 off the, well, we were on the sailing toward the Falkland Islands at the time, very close to the edge of the eclipse, so it was in eclipse right at sunset. And pictured there in the lower right is one from my wife. She can see the chromosphere in it and some prominences, but the corona in this case is very, very washed out, just as a kind of a feathery glow on the top left of this image. So nevertheless, it was one of my most spectacular eclipses. And not only that, it was spectacular, the trips that you made and the things that you saw cruising through the islands surrounding Antarctica and on Antarctica itself. And the thing that struck me most about this was one day pulling on one island and looking out over the landscape and seeing what our guide said was probably 1 million penguins. Now, this is only a part of the scene, but you can imagine that all around you and stretching across all of the hills way off in the distance of this picture. And those little brown fuzzy things are actually young penguins that haven't molted, and they will be getting their coloring. Some of them were already their final feathers before they proceed out into the ocean. But that's what eclipse travel is spectacular sights in spectacular places, along with the spectacle of the eclipse itself. Okay, let's go back and talk about the sun. So the part of the sun you see, which you try not to look at very much, is called the photosphere. And if you look at it through a filter and the eclipse glasses that you have, you'll see something like the picture, except that it won't have that big bite taken out of it. This is from a partial eclipse in New Mexico. So it's the visible layer of the sun, and you're not actually seeing a solid surface. You're looking at a surface that's a gas, actually. So you can actually see down into the photosphere for about 300 miles. And at the bottom of that 300 miles, the temperature is about 11,000 degrees Fahrenheit. And at the top, right up against where we stop seeing it as a visible surface, it's about 6,700. Now, the sunspots, in underneath the surface of the sun, there's a big tangle of magnetic fields. And you get a better feeling for that in a picture I have later on. But these things wind themselves up to the point where they get so much tension and energy that they pop out through the surface of the sun, kind of like the way the old cartoons used to show the springs in a bed popping out of the bed. So if you were to take a spring and wind it up, it eventually gets so tight that it would form a little loop. And that's what's happening here in the sun. And where these sunspots, where these magnetic fields come out of the sun, it suppresses the flow of radiation. And so they appear to be a little cooler. If you were to take them out of the sun, they would glow, but up against that much hotter surface, they look dark. So this is what you see as the eclipse starts, and you usually will try and contrast the darkness of the moon against the darkness of the sunspots, and you'll see that they're not actually black. Above the photosphere is the chromosphere, which I mentioned once before, and it appears only for about 10 seconds in a typical eclipse. But some eclipses are so short, the moon is barely able to cover the sun, that the chromosphere may be visible almost the entire diameter of the sun for a very short time. So what's happening here is the moon has moved far enough that it's covered the entire photosphere, but it still hasn't covered the last layer of the sun's atmosphere, and so that glows as red. And it glows red because it's mostly hydrogen gas that's essentially fluorescing. Its electrons have been removed from the hydrogen atom, and then when these electrons combine back with the atom, they glow in this deep red color. And so it's only visible in the time that it takes the moon to move that 1,500-mile distance in its orbit. It's a beautiful part of an eclipse. It's pretty short because you're only mostly going to see it right at the start of totality and right at the end of totality on the opposite side of the sun. This picture taken from Australia, but in a tour we did to New Guinea and to Australia. A fantastic tour on a expedition boat. So you can see the chromosphere is kind of interesting. It's up against the photosphere, so the bottom of it has a temperature of 6,700 degrees, but the top of the chromosphere has a temperature of 45,000 degrees. And right on top of that is a part of the chromosphere where the temperature rises to almost 1,000,000 degrees. And this is the primary focus of most scientific research that's done at an eclipse. What causes the temperature to go up to 900,000 degrees Fahrenheit from 6,700 Fahrenheit in a small distance? Where does the energy come from? It's like putting a pot on the stove. The stove may be at 400 or 800 degrees, but the pot's at 120,000 degrees, and how the heck did we get all that heat? And that's a bit of a mystery, but it seems to be tied up with magnetic fields on the sun. And this is what magnetic fields on the sun look like. And you can see they come out of sunspot areas, they curl back into other sunspot areas, form big loops. They have parts that stream out at the top here, just out into space, or up in the top right, they stream out, and those represent the polar structures that we were looking at earlier. And you can see these arcs. You can imagine that each one of these magnetic arcs has got gas in it, and when you see them up against the edge of the sun, those are the things that form the loops in the corona that you see during a total eclipse. Over here on the left-hand side, we've got a map of those regions and how the temperature jumps so quickly. You can notice that's a logarithmic scale, so for temperature goes from 10,000 degrees to nearly 1,000,000 degrees in an extremely small distance. Something is happening there. We're still trying to untangle what it is that's happening. Prominences are the so-called flames on the edge of the sun. This picture shows some chromosphere at the top and bottom, and the prominence in the middle. It's an unusual picture because it was taken during an annular eclipse, not a total eclipse. So you would not be able to see this by eye because the bright part of the sun is too bright to look at and too dangerous to look at. But you can photograph it if your camera is capable of being pointed at the sun. And when you do that, you can get these pictures. It's more an achievement showing that it can be done rather than showing anything prominently or even well. Well, prominences are strange beasts in a way. They have active prominences, erupting prominences, which are speeding outward from the sun and then falling back into it at very, very high velocities. And you have prominences which last for weeks or longer, which are just kind of floating there. And if you follow them with a high resolution telescope, you'll find most often it's material that's falling down toward the sun, not flowing up from the sun, unless it's actually erupting. They're very, very interesting structures on the edge of an eclipse. And sometimes you have a few of them, and sometimes you have many of them. You can see here over on the right-hand side that there's a sort of void or dark area above the prominence at the top of that picture. And those little arcs that you see are the magnetic fields that's trapped the gas that's being illuminated, glowing in that part. And those are actually interesting parts of a solar eclipse. You can see there's more of them down toward the edge of that picture. If you go to the picture on the left, you can see these little voids over some parts of the prominences there. There are prominences down attached to the chromosphere, and then there are some that are floating high above, as in that left-hand picture. You could spend a lot of time watching prominences, but of course you have 3.5 minutes or 4 minutes to do this. And so you have to divide all your attention between this wonderful lace-like structure in the chromosphere and then the prominences themselves and everything else that's happening. And that's why you go to more than one eclipse if you can. So what are you looking at when you're looking at the corona? Well, you're looking at light that comes from two different sources primarily, or three if you want to break it into finer detail. The region labeled E is light that comes from ionized atoms, or at least part of the light is coming from ionized atoms. And these are atoms where the high temperatures and magnetic fields and the turbulence have stripped electrons off of the atom, and as the electrons come back onto the atom, they give off light. And so you get, they're glowing, essentially, much like a fluorescent tube, the old style. Just electric current that's causing electrons to lose, to be stripped off of atoms and then recombining. The K corona is from the electrons themselves. Free electrons are actually reflecting sunlight. You see that, you usually see that a little farther out, almost two radiuses, 3 radiuses from the solar surface, and then they fade away. And finally, the F corona, the part that extends the farthest, is actually dust that's scattering light from the sun. And that dust has still got some structure in it because it's caught in the magnetic field. And this dust actually never disappears. It just goes on and on and on. But if you go out in the spring, early in the or late at night, or in the fall in the morning, you can find something called the zodiacal light. And this F corona actually blends into the zodiacal light. The zodiacal light is actually light that's reflected from dust that's in the plane of the Earth's orbit. And they're about almost the brightness of the Milky Way. So if you've got really nice dark skies, you can actually go out in March and in September, October to look for the zodiacal light. Pretty easy to see, actually. The shape of the corona changes too, according to the cycle of the sun. Now, this is a current image showing the cycle of the sun. You can see we're coming up toward the peak of the cycle, a maximum. And when you have a corona, you have a corona that's got the shape roughly like the one in the lower left there, where the corona surrounds the whole sun with these helmet streamers coming out from all different directions. Whereas if you go at a minimum eclipse, and we won't be down to a minimum until around 2030, 2032, but if you go to a minimum eclipse, you see that the corona tends to stream out to the sides and not so much toward the north and south poles of the sun. So we're going to be seeing somewhat rounder corona than a streaming corona in this eclipse that's coming up. to get away from the sun and talk about some of the other things. And here's a list of them that's sort of coming up in the next few slides. And all of these are things that will take away your view of the sun and the chromosphere. So they're things that you should watch for, but you don't want to spend a lot of time on some of them because after all, you came for the eclipse, and some of these things are just not that important, except to be able to say you've seen them. We'll go through them. Let's have a look at them. So about a half hour before totality starts, which we call second contact. First contact is when the moon first touches the sun. Second contact is the start of totality. And third contact is the end of totality. So there's about 3-4 minutes between second and third, and there's about an hour between first and second. So anyway, this is the best picture I could find that sort of showed that the light wasn't quite the same. I think what's happening here is we're close enough to the eclipse time that the shadows in this picture are very sharp. You can see, looking at the tripods, that there's distinct dark lines there, and it gives a sort of, I don't know, just looking at this in my collection of pictures, I thought, you know, that this is different light than I get in most of the eclipses. But it's very hard to describe what that light is. Artists would have a better job at doing it than somebody who has a more scientific approach to eclipse. But about halfway between first and second contact, if you look for it, you'll notice that the light is somewhat eerie. And because it's well before totality, it's worth paying some attention to, and it'll get a little more extreme as you get more and more into totality itself. This picture was taken in Egypt. If you want to see an eclipse in Egypt, well, we got one coming for you in 2027 that actually goes right over top the Temple of Luxor, which is in the lower left here. And this eclipse track has good weather all the way from Spain to Egypt. So you can go almost anywhere along this track and be almost guaranteed seeing that eclipse. But if you really want to immerse yourself in Egypt and its pyramids, then you'll have to go to Luxor, which is just about right under the point of greatest eclipse there. The only thing I have to tell you is that the average high in August in Luxor is over 40 degrees Celsius. So you're looking at temperatures that are pushing the 100-degree mark in Fahrenheit. But it's Egypt, or it's Tunisia, or Libya's opened up, maybe even Libya. The thing you can do at eclipses is make pinhole images of the solar crescent, and you don't have to be in totality to do this. You can stay at home in Kalamazoo and do this. But if you cross your fingers and let the sun shine through those narrow gaps, squeeze them down, you'll start to see pinhole images of the crescent. And you'll see this underneath trees. You'll see it, somebody brings a colander along and lets the light shine through it. Some people make images punching holes in a board in a certain pattern. I've seen people do pictures of King Tut and take them to the Egyptian eclipse and let the sun shine through it and have all these little crescents on the ground that trace out the image. But this is the easiest way to do it. You can do this at any time with the sun, but the round images that you would create on the ground wouldn't attract attention the way a crescent does. You can look for planets, but this is one of those things that say, you know, why bother? At this eclipse that's coming, Venus is going to be off to the lower or below the sun, I guess, depending on where you're looking at it. It might not be quite this angle. Mercury is going to be above the sun or to the left of the sun a little bit. But Mercury is going to be very faint, and you're going to have to turn your eyes away from the eclipse to search for Mercury. Jupiter, well, you just wait till the sun sets, and Jupiter will be glowing there in the western sky. One interesting thing is there's a nice comet that's actually going to be in the sky at this eclipse. But again, that comet is pretty faint, and you probably see it much better after the sun sets than trying to find it during the eclipse. Venus is easy because you can see Venus long before totality when the sky starts to get dark. It's bright enough that finding it is no real big challenge, actually. So don't spend your time looking at planets. You can see those at any time of night when they're out. Now, viewing the eclipse shadow. You know, I've never really seen a distinct shadow in an eclipse, but this eclipse I'm showing you here was an extremely short one in Uganda that we went to, and because of that, the shadow is very narrow in the sky and on the ground. The eclipse itself was actually only 18 seconds long, and in fact, it was so short that on the upper right here, you can see a picture of the sun with one little bright bead of sunlight still showing. But notice that the chromosphere essentially goes completely around the moon. And the reason is that this moon was just barely able to cover the sun, making an extremely short eclipse, but also leaving the chromosphere visible for the whole time around it. That won't happen for the April eclipse. It's a long enough eclipse that you'll only see the chromosphere at the start and the end of totality. Anyway, this shadow is fairly easy to see in this picture because I've drawn a line to show you where it is. But when you are going to be looking at this eclipse, if you go to totality, you'll see it more like a wave of darkness that's coming toward you. Let me just show you what it's like. 60 seconds. Okay, watch for the shadow. You should be watching for the shadow. Take your glasses off.
Glasses off!
Watch in that direction for the shadow coming.
I can kind of see it in the back.
That's not the way you want to be looking right now.
30 seconds to go.
We're going to do it. Yes, yes, yes. Look at the corona around that. I mean the color, the cloud corona. There we go.
Here we go, diamonds coming, Bailey's beads.
Good girl. Let the buffer go.
Whoa!
There we go.
Gosh.
Whoa!
Oh, look at the chromosphere.
Yeah. Oh, that's marvelous.
Oh, chromosphere all the way around. Prominences at the top at 12 o'clock.
Where's the shadow? Look at how bright it is all around up there. Diamond ring! And it's done. Oh, wonderful.
Oh my gosh.
If you were watching closely, you will notice that the sun moved from one side of the shadow to the other. And that movement was easily noticeable in this video. If you want to see the similar sort of thing at this eclipse or photograph it, I think you might be able to see something if you used a very wide angle lens, and then you would notice that the sun moved across the shadow, or more correctly, the shadow moved across the sun. I haven't worked out the geography of that yet, but that's what a very short eclipse does for you. You can imagine trying to see all of the things we're going to talk about in such a very, very short time. But of course, that eclipse took place in Uganda. In Uganda, you can go on safaris, and every eclipse in Africa is a safari opportunity. Marvelous safaris, been on quite a few of them because of the number of eclipses that were in that continent. And unfortunately, except for that one that's going across the Mediterranean I just showed you, there actually aren't very many eclipses coming up in Africa. A little bit of a decade-long drought of them that would give you an excuse to go and see something of the continent. A shadow like the one I'm showing you here is more like the kind of shadow we're likely to run into in April. So we're looking at the picture in the top middle here, which is taken from an eclipse in Russia in a place called Novosibirsk, which is in Siberia. And you can see there's a general darkness in the middle of the image with the sun in one part of it. And this is in eclipse at the time. But there's no actually well-defined edge that there was in that eclipse shadow that I just showed you from Uganda. But again, another wonderful opportunity. We watched it from a beach on a lake outside Novosibirsk, and you can see our groups were partly set up here, and a lot of Russians in the distance taking advantage of the sun and good weather to be out on the beach themselves. So we had actually a lot of people in bikinis and bathing suits coming up to look through our telescopes at the eclipse. I actually had a small telescope, but I had to regulate the amount of time people get to look through it because there were so many of them. So I was giving them only about 5 to 8 seconds each to look, and then the next person had to come along. We did have the opportunity in the upper right to try out the mock-up of the Mir space station. In the lower left, we traveled on the Trans-Siberian Highway, and of course the wonderful sights in Moscow and Leningrad, as it was then, to St. Petersburg now. Wonderful sights in the museums and everything else. But once again, the eclipse is as much the sun as it is travel. Shadow bands are something that you're going to hear people talk a lot about, and they are like ripples of shadow and sunlight that go across the ground very rapidly. It's very hard to tell which direction they're moving because they're so ephemeral. I don't recommend you look for them. You just wait till somebody shouts out shadow bands and then look down on the ground and watch them rippling by. But because these occur just before totality starts and just afterwards, you're probably better off to be concentrating on the sun and watching other things other than shadow bands. Still, they do happen about a minute ahead of totality, so there is time to spend a bit of attention, pay them a bit of attention. This is when it really gets exciting, when we get to so-called Bailey's beads. And the limb of the moon is not a smooth surface. It's got lots of little indentations on it, valleys and mountain peaks. And so when you get to an extremely small part of the photosphere, it begins to break up into these little beads. And each one of these beads is where the sun is shining through a valley on the edge of the moon. And any one of the interruptions is when a piece of higher ground or a mountain is sticking up. And so you get this gradual transition from the left of seeing a long arc of sunlight as you gradually move into the eclipse. And this set of pictures was taken over probably a 3 or 4 second time period. But as you move into eclipse, you see that the beads gradually disappear until they're all gone. And that is actually quite a spectacular part of the eclipse. Now, the problem you have here is, do you keep your glasses on to watch these, or do you watch them without your glasses? If you're a photographer, you take the filters off because you're not going to get this kind of a picture with the filter on. And this is especially nice because the chromosphere is so nice. But even there on the right-hand side, you can see the chromosphere is starting to break up into little beads because the same thing that happened with photospheres is going to happen with the chromosphere as well. Visually, I would suggest that you leave your glasses on to watch this at the start of the eclipse, but you might want to leave your glasses off and watch it visually for at least 4 or 5 seconds after the eclipse. And of course, the very last bead, when there's only one left, is what's called the diamond ring. It was Francis Bailey that first described them, but people have actually been seeing them for quite a long time before that, back into medieval times. So here's some little ideas on when you might want to take off your glasses. The main reason for leaving your glasses on until totality starts is that if you take them off while there's still a diamond ring or something else, you're going to dazzle your eyes, and the next thing you know, you're not going to see as much of the corona. If you really want to see the corona, you do, like my wife Judy is doing here, is you tape something over one eye. You block one eye, and that way you dark adapt on that eye. And so when the eclipse comes, you take the tape off and you get a much broader view of the corona. Something akin to the kind of pictures that Dr. Druckmuller was showing, and I showed you earlier. She's only tried this on 2 eclipses, but I think it's going to be something she does to every eclipse from now, because she told me that the view of the corona was far better than any that she'd ever seen before. And we've been to 25 total, so she's seen her share of corona. I might even try that myself, except I block off my right eye. I'm half blind in my left eye. The nice thing about the eclipse is the way you feel connected. Now here's a picture before a totality and during totality, and all of a sudden you realize with this fisheye lens that you're actually in the midst of this enormous shadow. And if you look around you and see this bright horizon, you'll get some of that impression, but it really only shows up best where you have this kind of a lens that shows you everything at once. You're in the middle of a bullseye. You're connected here. You're connected from the earth to the moon to the sun. And it's just this wonderful feeling when you can just sit back, don't photograph it. I just left the camera running, take this, and just look at it, just watch it, just get the feeling of this immense event that's going on, and you're right at the focus of it. Beads again, but now we're talking about the last bead or the first bead. The last bead as you're going into eclipse at second contact, and the first bead that appears when you're coming out of eclipse. Sometimes it's not one bead, sometimes it could be a couple, because it depends on what the profile on the edge of the moon is. But you can see that the corona is still visible in this picture. And so it has a resemblance of a diamond ring with a bright diamond in one part. So I suggest that you watch this with a filter at the start of the eclipse so that your eyes are at least partly dark adapted, but feel free to watch them without a filter as it comes out from the sun. Most people do 4, 5, or 10 seconds, and then they put the glasses on. You'll dazzle your eyes after that, but it is short enough time you won't do any damage to your eyes. If you're going to propose to somebody at this point, and that happens, do it at the second diamond ring, not the first one, because otherwise you'll miss the whole eclipse. So here it is summarized for you in the slide I made up. Everything is there, and it's okay. The first notch of the sun over here on the left side, and then you start to watch the sunspots as the moon covers them. You notice the temperature changing about halfway in. When you still got a half hour, 15 minutes to go, Venus appears, and the rest of the planets, maybe not, Jupiter perhaps, but you'll start to make crescents on the ground and see the shadows. So one thing we didn't talk about is how sharp the shadows get as you get in toward an eclipse. And then when you get right into the minute of second contact, all these things that you have to watch for. Some of them are very, very short, such as the Bailey's beads and the chromosphere. A flash spectrum is something for specialists. That's I'm not talking about that, but you can take a diffraction grating and watch the spectrum of the sun there. Once you're into eclipse, we have 5 things I've noted: the prominences, the polar brushes. You could talk about the helmet plumes and things like that. You can watch the wildlife and see what's happening in there, and look around the horizon and see what the lighting looks like. But most of these last 2, the horizon light and wildlife, are not as important as looking at the corona and the structures around it. And then when we come out of eclipse, everything gets done in reverse again. There's enough things happening, especially in that 4.5 minutes for this eclipse, depending on where you are, is that when it's all over and you start talking about it, you realize that some of the things you meant to see, you didn't, or people saw things that you didn't notice. And of course, The only thing you can do is go see another one. My wife Judy likes to draw pictures of what she's seen, even though she does the photography in our little trips. I quit doing that about 10 eclipses ago. She has the ability to remember what's going on. She draws what she saw and comments along the way, what it felt like and that sort of thing. And that's really, if you have the ability to do that, or even talk into a tape recorder what you're seeing, then you will remember far more about this eclipse. I go back and remember the eclipses I've seen. I don't remember the eclipse itself, except in very few cases. I remember where I was and what I'd done to get there and what I'd seen along the way. But drawing is certainly a very good way to fix it into your memory. And this is actually a far more precious record, I think, than the photography itself. In the end, it's all about connections. It's a connection to the solar system when you find yourself in the middle of that shadow. It's a connection to a time and place. And you're going to talk about when you saw the 2024 eclipse or the 2017 eclipse or both of them. It's a connection between you and all the people around you, like these folks here in the bottom picture. These are people I met in 1991 eclipse. And I still remember them. I still wonder what's happened to them. I know some of them have passed on since then, but I still have fond memories of sharing that eclipse with them. You're also connected to this history, to the Babylonians with their tablets here. You're connected to, if you collect eclipse stamps, and there's a goodly number of those, if you like to take up a little collection, then you're connected in a way to the art and philately of it. But you're also connected to the events, the discoveries in the 1800s and the 1900s, and to Halley and his maps and everything else. You're connected to travel, and you'll discuss your travel as a real adventure. And when you go to many eclipses, you meet many of the same people again, and you make friends with them all over again every time. But the one thing I think that's best about eclipses is this last thing. In 2017 eclipse, I drove across the United States from one side to the other along the eclipse track. When I talked to people about an eclipse, they always said to me, yeah, my dad took me out when I was 8 years old and showed me an eclipse. Or my grandfather, my dad, and I went out to watch an eclipse when I was about 10. And so there's this enormous connection between the present and the past. And later on, from the present to the future, when your sons and your daughters and your grandchildren go along with you to watch these things. So the eclipse is this marvelous collection, and it's all a non-hazardous collection. It doesn't make you fat, and it just gives you this wonderful glow every time you start to remember it. So thank you very much for watching. I hope you all have clear skies in the future. I'm going to show you a couple of links in the next slide, which I'll leave up, and I'll stop the share after a minute or two, and we'll answer any questions that we can. But once again, thank you very much. You might want to grab your cell phone, take a picture of that, but this is being recorded, and you'll be able to find them readily enough. Weather will become a more important part about your eclipse as time goes on. So things like windy.com, which I look for satellite pictures and models of the weather, is a very handy site to go to. And also the one above it, that the weather.cod. COD is the College of DuPage near Chicago, and they have mostly set up for storm chasers, but they've got good access to satellite computers.